Yes. Continuation of the periodic table chapter. Next property is ionization potential. Or ionization energy. This is often called as a IP values or IE values. IP values or IE values. Now, what do you mean by IP values or IE values? Now, this is nucleus of an atom. Nucleus of an atom. Next to the nucleus, we have different shells and subshells. We have shells and subshells. Electrons are present, like that of the K shell, L shell, M shell, N shell, and O shell, and so on. That is the principal quantum number values, like 1, 2, 3, 4, and 5, and so on. Is it clear? Now, usually the outermost shell electrons, these are called as valence electrons. These outermost electrons are called as valence electrons. When these valence electrons are present in the higher energy level, during the chemical reactions, these are involved. When certain amount of the energy is applied, then we can knock out the electrons very easily. We can remove the electrons very easily. The minimum amount of the energy required to remove an electron in the neutral gaseous isolated state of an atom in the higher energy level is called ionization energy or ionization potential. But that should be in the neutral gaseous isolated state. First you have to convert the element into the vapor state. In solid state we can unable to remove an electron because all are compactly packed. In the vapor state, in the gaseous state, only we can remove an electron very easily. Therefore, you have to convert the element into the vapor state of an element or gaseous state of an element. In the gaseous state of an element, you have to apply additional amount of the energy. Then we can remove an electron very easily. Therefore, ionization potential or ionization energy is accompanied by the absorption of the heat energy. Is it clear? Therefore, always heat energy is required or energy is required. Therefore, it is an endothermic process. Delta H of the process is always positive. Delta H of the process is always positive. Is it clear? Therefore, it is an endothermic process. It is an endothermic process. Endothermic process. Therefore, delta H of the system is always positive. Delta H of the system is always positive. Is it clear? Therefore, now what do you mean by definition of the ionization energy? This is the minimum amount of the energy required to remove an electron from the neutral gaseous isolated state of an atom. Now that should be in the higher energy level. That should be in the higher energy level. That should be in the higher energy level. If one electron is there, then no problem. If two electrons are there, now we have to remove the second electron also. We have to remove the second electron also. For example, in sodium, now can we remove an electron very easily? The first electron. Then we can convert into Na plus 1A. Na plus 1A. The amount of the energy required the amount of energy is required. Similarly, to the potassium, we can convert into potassium cation plus electron. One electron is lost. One electron is lost. During the formation of the cations, we have to supply the additional amount of the energy. That is called as a IE1. That is called as a IE1. IE1 refers to first ionization energy. The amount of the energy required to remove an electron, that is second electron, that is called second ionization energy. Second ionization energy. The amount of the energy required to remove an electron, third electron, that is called third ionization energy. Third ionization energy. Make ensure that the third ionization energy is higher than that of the second ionization energy. Second ionization energy is higher than that of the first ionization energy. Therefore, ionization energy values are in the order I3 greater than I2 greater than I1. Now that should be in gaseous state. This should be in gaseous state. Now this is also in gaseous state. This should be in gaseous state and also this should be in gaseous state. What about the delta, that is value, IP values? The IP values, that is equal to 495.5, that is in the form of kilojoules. That is a plus value, that is the plus value, that is the endothermic process. Delta H is equal to positive, therefore that is a plus value. IA is equal to, therefore IE1, that is equal to plus 495.5 kilojoules. But here that is equal to 419 kilojoules. 419 kilojoules. That is IE1 is equal to plus 419 kilojoules. 419 kilojoules. That is per mole of an element. That is per mole of an element. This is per mole of an element. Per mole of an element. Here also this is per mole of an element. What is per mole of an element? That is for one Avogadro number of electrons. That is for one Avogadro number of the electrons. This implies for 23 gram of sodium, that corresponds to 1 mole of sodium. 1 mole of sodium. It requires plus 495.5 kilojoules. 5 kilojoules. Now what does it mean? That is for 39 gram of potassium, that corresponds to 1 mole, that is 419 kilojoules of energy is required. In your entrance exam, they may give other than 23. Suppose they may give 11.5 gram. For 11.5 gram of sodium in vapor state, then the amount of energy is required 495.5 divided by 2 kilojoules. 495.5 by 2 kilojoules. If it is that is equal to, for suppose this is equal to 5.7, that is equal to 5.75 gram, 5.75 gram of sodium, then with respect to 23, then it is equal to a quarter, therefore that is equal to 495.5 divided by 4 kilojoules of energy. 4 kilojoules of energy. Now what is its value? What is its value? 495.5 divided by 2. 495.5 divided by 2. $495.5 divided by 2, 247.75 kilojoules. 247.75 kilojoules. Whereas this is 495.5 divided by 4, that is 123.875 kilojoules. 875 kilojoules. On the other hand, they may ask for 1 gram. For 1 gram, if they ask for 1 gram of sodium in the form of the vapor, then that is equal to 495.5 divided by 23. That is equal to how much? 495.5 divided by 23. In your entrance exam, they will give the problems like this. That is a 495.5 divided by 23. That is 21.54 kilojoules. Suppose if it is a 1 gram of the sodium is there, then how much amount of the energy is required? That is equal to 21.54 kilojoules. It is an extensive quantity. Extensive quantity means it depends upon the quantity of the substance. It depends upon the size of the substance. It depends upon the moles of the substance. Such properties are called extensive properties. Therefore, it is an endothermic process and extensive property. Extensive property. Extensive property. Very important one. In your entrance exam, they will give which one of the following is an extensive property, which one of the following is an endothermic reaction or endothermic process. Then you can give an example. Therefore, ionization energy is an endothermic in nature. Ionization energy is an extensive property. Ionization energy is an extensive property. Now, in your entrance exam, they may give this 39 gram. Therefore, they may give the various quantities. That half of this value means that is 19.5 gram. 19.5 gram. For 19.5 gram of potassium, that is in the form of vapor phase, then the amount of energy is required 419 divided by 2, that is equal to 209.5 kilojoules. 209.5 kilojoules. So that is the quantity of the energy required to remove an electron from 19.5 gram of the potassium. In your entrance exam, they may give the various questions like this, but you should know about that what about the quantity is there, that is for 1 mole of the substance. That is for 1 mole of the substance. Now, what are the various factors? For example, in case of the aluminium, for aluminium, how many electrons are there? 3 electrons are there. 3 electrons in outer shell. Outer shell. That is atomic number 13. It can be rewritten as 2,8,3. 2,8,3. Therefore, aluminium having 30 number of the electrons, it is in the form of the gaseous state. It is in the form of the gas state. To remove the first electron, then Al plus. First electron. For first electron, that is Al plus 2A. Al plus 2A. Whereas Al plus, that gives rise to Al2 plus 1A. Al2 plus, that gives rise to Al3 plus. This is for Al plus to remove the first electron. This is for removal of the second electron. For second electron. For second electron. This is called IE1 value. This is called IE2 value. This is for third electron. This is for third electron. This is IE3 value. First ionization energy, second ionization energy, and third ionization energy. This is 576 kilojoules per mole. Delta H is equal to plus 576 kilojoules per mole. For the removal of the second electron, it should be 1803 kilojoules per mole. Delta H is equal to plus 1803 kilojoules per mole. For the removal of the third electron, it is found that 2723 kilojoules. That is delta H is equal to plus 2723 kilojoules per mole. This implies that third ionization energy is greater than second ionization energy is greater than first ionization energy. Third ionization energy is always greater than the second ionization energy. Second ionization energy is always greater than the first ionization energy. Why this is due to? See, whenever one electron is lost from the higher energy level, the number of electron in ion, now it is not an atom, now it is an ion. Cations are found. Ionization energy is the tendency for the formation of the cations. Therefore, in the cation, the number of the protons are same as that of the neutral atom, because we are not removing the neutron, that is a neutral species, or that of the positive charge species present in the nucleus of an atom. What about the electron? Electron number is decreased, but proton number remains constant, and neutron number remains constant, because they are present in the nucleus of an atom. And hence, the effective nuclear charge will be more. Effective nuclear charge will be more. That is nothing but proton number is greater than that of the electron number. This is called the effective nuclear charge. Effective nuclear charge is nothing but the positive charge present in the nucleus of an atom. Ion, nucleus of an ion. Therefore, then whenever the nuclear force of attraction will be more, then more amount of the energy is required to remove the second electron. Therefore, the second ionization potential is always greater than the first ionization potential due to the decrease in the size of an ion. Whenever the ionic size is smaller, nuclear force of attraction will be higher, and hence more amount of the energy is required to remove an electron. Now, what about the third ionization energy? Third ionization energy is nothing but the removal of the third electron from an ion. Third electron from an ion. First electron from an atom, second electron from an ion, third electron from an ion. Therefore, whenever the third electron is there in the higher energy level, then the ionic size further decreases. Ionic size further decreases. This implies that the outer electron is very close to that of the nucleus, not far from the nucleus, very close to the nucleus. When you remove an electron from the higher energy level, the remaining electron present in the higher energy level that offers more attractive force towards that of the nucleus due to the increase in the nuclear force of attraction, and hence more amount of the energy is required. That is why third ionization energy is greater than the second ionization energy. Second ionization energy is greater than the first ionization energy. In your the board exam, they will ask the one more question. Second ionization energy is always greater than the first ionization energy. That is true. Therefore, due to the increase in the nuclear force of attraction or due to the decrease in the ionic size, you can give any one of the reason. This is about the ionization potential. Now, what are the various factors that decide the ionization potential value? various factors that depends on the ionization potential value. What are the various factors? First factor is atomic size. First factor is atomic size. Atomic size. What about the second factor? Second factor is effective nuclear charge that I mentioned. That is effective nuclear charge. Effective nuclear charge. Effective nuclear charge. What about the third factor that depends upon the ionization potential value? That depends upon the shielding effect. That depends upon the shielding effect. Shielding effect or screening effect. Fourth factor is half-filled atomic orbitals. Half-filled atomic orbitals. Last factor is electrons present in removal of the electrons from sp, d and f atomic orbitals. Removal of electrons in s, p, d and f atomic orbitals. Removal of electrons in s, p, d and f atomic orbitals. Now these are the various factors that decides the ionization potential values. Now what do you mean by atomic size and how it is related to? Higher is the value of the atomic size, lower the value of the ionization potential. Higher is the value of atomic size. Higher is the value of atomic size. Higher is the value of atomic size. Smaller is the ionization energy or ionization potential. This implies ionization potential is inversely proportional to atomic size. Ionization potential is inversely proportional to atomic size. Now, along the period and down the group. This is along the period. Along the period. Along the period. What about the trend in atomic size? Along the period, atomic size decreases. Atomic size decreases. Along the period, atomic size decreases. Whenever along this period the atomic size decreases, ionization potential value increases. IP value increases. IP value increases. IP value increases. IP value increases. This is down the group. Down the group. This is nothing but down the group. What do you mean by down the group? Atomic size increases. Down the group. Atomic size increases. Down the group, atomic size increases. Atomic size increases in the sense IP value decreases. IP value decreases. This implies that smaller the value of IP, smaller the value of IP, smaller the value of the IP, higher atomic size, higher atomic size, higher atomic size, metallic nature predominates. Metallic nature predominates. Metallic nature predominates. This implies that for metal atoms, ionization potential value is smaller. For alkali metals, IP value is very small. IP value is very small. IP value is very small. Therefore, in your entrance exam, they will give the 4 values, IP values of the 4 elements. This is X kilojoules, this is Y kilojoules, this is Z kilojoules, like that they may give. Then if suppose it is a metal, then for X is a metal, IP value is minimum. For non-metals, IP value is maximum. For non-metals, IP value is maximum. For non-metals, IP value is more. For non-metals, IP value is more. For non-metals, IP value is more. Therefore, whenever the IP value is small, they are good reducing agents. Whenever the IP value is large, they are good oxidizing agents. Therefore, based upon this, we can predict smaller is the IP value, reducing agent. Smaller is the IP value. That is a reducing agent. Smaller is the IP value, reducing agent. Higher is the IP value, oxidizing agent. Higher is the IP value, oxidizing agent. That is why P block elements with higher ionization potential or high ionization energy, they are good oxidizing agents. Alkali metals and alkali earth metals family, they have the lower value of the ionization potential, they are good reducing agents. Therefore, we can predict the given element is whether oxidizing agent or reducing agent based upon the value of the ionization potential. That is why atomic size. The concept is smaller is the value of the ionization potential, higher is the atomic size, or higher the value of the atomic size, smaller is the ionization potential. Next one is effective nuclear charge. Effective nuclear charge means that is the number of the protons. That is directly proportional to. Effective nuclear charge. IP value is directly proportional to effective nuclear charge. IP value is directly proportional to the effective nuclear charge. This implies that the higher number of the protons are there within the nucleus, attractive force will be more for the remaining electrons in the higher energy level or outer shell or outer atomic orbital. Therefore, whenever the nuclear charge will be more, then the more attractive force is there between the nuclear charge, that is the protons, with that of the higher energy level electrons. Therefore, more amount of the energy is required to remove an electron in the neutral gaseous isolated state of an atom. Therefore, IP value is directly proportional to the effective nuclear charge. Smaller is the value of the ionization potential. Smaller the value of the ionization potential. Then smaller is the IP value. Smaller is the value of the ionization potential. The effective nuclear charge is very small. Now, next one is the shielding effect or screening effect. If the more number of the inner atomic orbital electrons are there, then higher energy level electron that does not impose the same attractive force on the nucleus. Therefore, as shielding effect increases, then inner atomic orbitals or inner shells increases, or more number of the inner atomic orbital electrons will be there. Then what happens? This happens where the shielding effect that gradually decreases down the group. Therefore, the ionization potential value decreases. Therefore, shielding effect, higher the shielding effect, smaller is the ionization potential. Therefore, shielding effect is inversely proportional to the ionization potential values. Why this is due to? Because whenever the ionization potential value that depends upon the inner atomic orbital electrons. As the inner atomic orbital electrons increases, as the inner shell number values that increases, as the inner orbitals increases, what happens? The attractive force between the higher energy level electron with that of the nucleus is very less. Whenever the shields that increases, what happens? Whenever the screen numbers are increases, then assume this is the nucleus, then I will keep one layer, second layer, third layer, fourth layer screen. If the only one layer screen is there, then affinity is more. If the two screens are there, then affinity is less. When 3 screens, 4 screens are there, affinity is still less. Therefore, when you move down the group, the screening effect that gradually decreases, or shielding effect that gradually decreases. Therefore, a higher energy level electron that does not impose any force of attraction with that of the nucleus, and hence the ionization potential value is very less. Therefore, IP value is inversely proportional to the shielding effect. Inversely proportional to the shielding effect. Ionization potential is inversely proportional to the shielding effect. Why this is due to? That is because of increasing number of the inner atomic orbital electrons. Whenever the inner atomic orbital electrons increases, then for the outer atomic orbital electrons, the attractive force is very less with that of the nuclear charge. That is the number of protons present in the nucleus. Therefore, whenever the force of attraction is very less, then lesser amount of the energy is required to remove an electron. Okay. Now this is half-filled atomic orbitals. Now see, especially when in case of the half-filled atomic orbitals, suppose the P3 atomic orbital is there, or P6 atomic orbital is there, or for D5 atomic orbitals and for D10 atomic orbitals, for F7 atomic orbitals and F14 atomic orbitals, or for S2 atomic orbitals. Then what happens for P3 atomic orbital is half-filled atomic orbital, D5 atomic orbital is half-filled atomic orbital, for F7 atomic orbital is half-filled atomic orbital, S2 atomic orbital is completely filled atomic orbital. Now, you know that this is very stable. P6 atomic orbital, very stable. F14 atomic orbital, very stable. Like that of the completely filled atomic orbitals, which are more stable, like that of the P3 or D5 or F7, these are called as a half-filled atomic orbitals. Half-filled atomic orbitals are very stable one. Half-filled atomic orbitals are very stable one. For example, you know that air is a homogeneous mixture of nitrogen and oxygen. Nitrogen has half-filled atomic orbital. That is P3 configuration. Here no half-filled atomic orbitals. Now, because of this half-filled atomic orbital in case of nitrogen, therefore, whenever C6H12O6 glucose, when exposed to air, you are telling carbon dioxide and water are formed. But N2 of air, no reaction towards respiration process. Therefore, you are inhaling air or oxygen. You are inhaling air for respiration process. When you are inhaling air for respiration process, this indirectly implies that you are inhaling oxygen and nitrogen. But during combustion chemical reaction, glucose part that would react with oxygen part of the air, but not nitrogen part of the air. Because nitrogen is very stable towards that of the oxidation reaction because of P3 configuration. When you write the electronic configuration of the nitrogen, we have 1s2, 2s2, 2p3 configuration. Because of this reason, it is very stable. Similarly, like that of the half-filled atomic orbitals are there. D5 atomic orbital and F7 atomic orbitals. These are half-filled atomic orbitals, which are very stable towards that of the chemical reactions. Therefore, in such cases, more amount of the energy is required. Therefore, half-filled atomic orbitals that provides that requires higher amount of the energy to remove electron from the higher energy level. Is it clear? Yes. That is why nitrogen ionization potential is very large. Now the last one is removal of the electrons. Last one is removal of the electrons in SPDF atomic orbitals. In the same shell, So for example, in the same shell, we have the S, P, D and F all atomic orbitals. S atomic orbital is very close to the nucleus. S atomic orbital is very close to the nucleus. Therefore, S atomic orbital electrons that offers more attractive force towards that of the nucleus. Therefore, energy required to remove an electron from the S atomic orbital is more. When you compare that of the P atomic orbitals, somewhat far away from that of the nucleus. Therefore, these are electrons that act as shielding electrons. Therefore, the amount of energy required to remove an electron is very less compared to that of the S atomic orbital electrons. When the D atomic orbitals are there, S and P atomic orbitals, they behave like a shielding electrons, shielding effect or screening effect. Therefore, amount of energy required to remove an electron in the D atomic orbital would be very less. When the F atomic orbital electrons are there, then SP-D atomic orbital electrons, they seems to be the shielding electrons for that of the F atomic orbital. Therefore, F atomic orbital that offers no attractive force with that of the nucleus due to the inner shielding electrons of S atomic orbital, P atomic orbital and D atomic orbital. Therefore, that is in the order S atomic orbital electrons that requires that less amount of that ionization potential values are that of the, whereas we can remove electron very easily. F atomic orbital electron, we can remove an electron very easily. Therefore, ionization potential that would be very smaller one. Therefore, the higher value of the ionization potential is there, smaller value of the ionization potential is there, still smaller value of the ionization potential is there, least value of the ionization potential. Therefore, S atomic orbital electrons ionization potential will be very high. For F atomic orbital ionization potential is very small compared to that of the D atomic orbital. Therefore, D atomic orbital, F atomic orbital. When you compare, we can remove an electron from the F atomic orbital very easily. F atomic orbital very easily. Therefore, in such cases, IP values are S greater than P greater than D greater than F for the same shell. If suppose SPDF electrons from the different higher energy levels are there, then that will be different. But in the same shell, same main energy level, same principal quantum number, if suppose the S atomic orbital, P atomic orbital, D atomic orbital and F atomic orbital electrons are there, IP values for the F atomic orbital electrons are less because they offer no attractive force with that of the nucleus. Therefore, S atomic orbital electrons IP values are more compared to that of F atomic orbital electrons. Therefore, S greater than P greater than D greater than F. Is it clear? This is about the factors that influences the ionization potential values. Ionization potential values. Okay. Now, variation of IP values. Variation of IP values along the period and down the group. Along the period and down the group. Along the period and down the group. Now, IP values along the period increases due to decrease in atomic size. Due to decrease in atomic size. IP values down the group. IP values down the group decreases due to increase in atomic size, due to increase in atomic size. That is why they are non-metals. Higher the value of the IP value, non-metallic nature predominates. Lower the value of the IP value, metallic nature predominates. Is it clear? This is about the ionization potential value trend along the period and down the group. Is it clear? Now this is about the periodic properties of the elements. Periodic properties of the elements. Next one is the opposite compared to that of the ionization potential value, that is electron affinity. In the ionization potential value we can remove an electron, electron affinity value we can add an electron. During the addition of an electron, the negative the charges ions are obtained, which are nothing but the anions. Whereas in the ionization potential values, positive charged species are obtained, they are considered as cations. Therefore, ionization potential, keep in your mind, cations are formed. Electron affinity values, anions are formed. Ionization potential, electrons are removed. Electron affinity, electrons are added. Is it clear? Okay. We can discuss the electron affinity values in the next period. Okay. Thank you.